on this one, we have a similar situation. What's happening is that we're checking to see if every log term has the same base. And if you don't see a number here, like a subscript, then it's automatically the invisible understood 10. So they all have the same base. Only if it's not 10, you'll see some other number, like maybe 2, or any number really, that fits within the domain. Now, what's happening is that when the two log terms are on the same side, you have to combine them. And we made sure that they have the same base, so we can write the log term one time, or the log part one time. And then the first one, we can just put that directly. It's already positive. If you don't see a minus sign in front of the log term, it's automatically positive. Now, the next part, you just have to see, is it combined with addition or subtraction? Last time it was subtraction, so we needed a fraction. This time it's addition, so that's going to be that you're multiplying the two arguments together. And you could rearrange this, you could put the 3 in the front if you want. But at this point, or at some point, the next step would be that you distribute it anyway. So we can just do that now. You'd say that you have the log of 3x plus 9, like that. This one you can just bring straight down. There's nothing else to do until the next step. Now, on the next step, because they have the same base, and we have just the two log terms, one on each side, you can basically drop them out. Like, there's a way that you can show, like, here's one way, you're raising them both up to an exponent, but you don't have to do all that. You can just write 2x minus 1. We don't need the parentheses anymore either, because there's no modifier on the outside. And we're just solving these now. So this one, since this is the bigger of the two x's, and it's positive, I'll go ahead and bring this one over to the same side so that the x stays positive. And then the last thing is to move the 9 to the other side. So we end up with negative 10 equals x, or if you flip it around, x equals negative 10, same thing. But the important thing is with logarithmic equations, you have to check. Whereas with elimination or substitution, it was optional, where you're just checking if you want to make sure you have the right answer. With logarithmic equations, you always have to check. So you could check it as an entire equation, or it's a little faster if you just do it piece by piece. So these are the 3 pieces, and all of them were log terms. We're checking to see if negative 10 will go inside each expression or each term without making the value 0 or negative. So we'll start with the first one. And when you do this, you'd say it's 2 times negative 10 minus 1. And then that makes this negative 20 minus 1, which means that we have a negative number here. Now, the important thing is that this has to be greater than 0, and it's not. So that means that it didn't work out. And if it didn't work out here, it's not going to work out. You know, even if it does work out in the other ones, which it won't this time. But if it doesn't work out in even one of these, then you have to say that there's no solution. It's not going to work out for this equation. So this is a case where there's no solution.